Welcome to aminacademy.com. In Cambridge IGCSE Physics Theory Extended Paper, year June 2022. Let us solve. Look at this question. A car of mass m is traveling along a straight horizontal road at a constant speed v. At time t equals 0, that is starting point, the driver of the car sees an obstruction in the road ahead of the car and applies the brakes. The car does not begin to deaccelerate. That means car is not come to slow down at time t equals 0. Explain what is meant by deacceleration. Deacceleration means acceleration is reducing manner. That is called negative acceleration. That means decreasing velocity. We can say or it is decreasing velocity. Question B. Suggest one reason why the car does not begin to deaccelerate at t equal to 0. Maybe delay of applying a brakes, that is because of the human beings, some time delay for applying brake. Maybe time delay. Or the reaction time is more. Reaction time is more. Next question. Look at this figure. This figure is the distance time graph for the car from time t equal to 0. Time is in x-axis, distance is in y-axis. State the property of a distance time graph that corresponds to a speed. Here, the speed indicates the slope of the curve, gradient or slope of the curve. Gradient or slope of the this curve. Slope or gradient of the gradient is speed. It indicates speed of the vehicle. Using this figure, determine the initial speed v of the car. Here, the initial speed, how to calculate, look at here. Now, we have to take some points. Look at here, at time 1 second, this distance is 22 because here each is 20, then 10 lines are there, each small lines have 2. So the coordinate point is here 0 0, here 1 and 21. Coordinate points are 0 0 at x is 1, y is 22 because each point is 2 here, this point here. Now using slope formula for this, we can get it the gradient. The gradient is y2 minus y1 over x2 minus x1. y2 is 22 minus 0, 1 minus 0, which is equal to 22. Therefore, the velocity is 22 meter per second. Speed, initial speed v of the car. Next question. When a car is deaccelerating, there is a there is a constant relative resistive force F on the car due to the brakes. The deceleration of the car is greater than F over m. That is F over m is the mass and is not constant. Explain why the deceleration of the car is greater than F over m. Because of the air resistance, not only the brake by the brakes, by the air resistance also, that is acceleration is reducing, that is deceleration. So the deceleration of the car is greater than F over m because of air resistance, air friction. Air resistance or air friction act on the car. Air resistance acts on the car additional to the braking force. The deceleration is not constant. Why? The deceleration is not constant because of air resistance as well air resistance resistive force decreasing the speed. Resistive force of the air, the resistive force is reducing due to air friction. Therefore, deceleration is not constant. Next question. Look at this question number 2. Shows water stored in a reservoir behind the hydroelectric dam. Here water reservoir, and it is through the pipeline, it comes to the turbine, it runs the turbine and generator produces the electricity. Now look at this question. State the form of the energy stored in the water in the reservoir that is used to generate electricity. Is gravitational potential energy, because some height from the ground air is reserved, water is stored that have potential energy, that is gravitational potential energy. Because of the stored water is in high, so it has gravitational potential energy. The turbine is 150 meter below the level of the water in the reservoir. Turbine is here 150 meter below the water surface. Atmospheric pressure is 1 into 10 power 5 Pascal. The density of water is 1000 kg per meter cube. Calculate the total pressure in the water at the turbine. Yeah, pressure equal H rho G. Pressure P equal to H rho G. H is height, 150 meter. Rho density is 1000 for water and gravity is 10. So which gives 1.5 into 10 power 6. 10 power 6. That is pressure Newton meter square. Therefore, pressure is 1.5 into 10 power 6 Newton per meter square. Next one. The turbine has a cross-sectional area of 3.5 meters square. Calculate the force exerted on the turbine by the water. Here, we know that force, pressure into area. pressure we have 1.5 into 10 power 6 into 3.5 Newton. So which gives, so for multiplying it gives 5.6 into 10 power 6 Newton. Therefore, we have answered 5.6 into 10 power 6 Newton. That much force is available at the base of the turbine. Next question. The water flows to the turbine through a pipe, constant cross-sectional area. Explain why the kinetic energy of the water in the pipe remains constant as it flows through the pipe. Yeah. Here this in water, the speed of the water is mostly it is same because this inclination is not so much, the slope is very less, so the speed, let it be speed be constant. We assume the speed is constant, so speed of the water is remains constant, so the kinetic energy of the water in the pipeline remains constant. Kinetic energy of water is mostly constant since the speed of water in pipe, equal cross-sectional pipe, water is same, does not change. Water in pipe does not change. Since kinetic energy is half mv square, here v square, the formula is v square, half mv square. In that, mostly the velocity of the water is constant, that is the speed, the water is constant in pipeline, so its kinetic energy is mostly not changing, same. During the picnic on a warm, dry day, a metal can lemonade in wrapped in a damp cloth. That means some metal can inside is lemonade, cool lemonade, is wrapped with a damp cloth. Evaporation cools the water in the cloth. Evaporation cools the water in the cloth. Explain, because water is lemonade wrapped with a damp cloth. Damp cloth means it's cool the lemonade. Explain in terms of the molecules how evaporation cools the water in cloth. Yeah. Suppose if anything is hot, we understand these molecules are moving, wander here and there, moving fast. Explain the terms molecules, the evaporation cools the water. Here, due to evaporation, by evaporation, wandering molecules, speed of wandering molecules are reduced. So evaporation, so it cools. Therefore, it is cooled. That is evaporation cools. Therefore, evaporation cools the water in cloth. Cools the water. cools the water in coke. Next, as the water in the cloth cools, so does the lemonade. Explain how electrons transfer thermal energy through the metal of the can. That means it's by conduction, convection, and radiation. Three forms. By conduction, convection, and radiation. By this way, that electrons transfer thermal energy through the metal to the can. By using these methods, that is, electrons transfer thermal energy through the metal of the can and make it inside, make it the cool inside water, inside lemonade water. Next question. Thermocouple is a device that is used as a thermometer. Here, figure 4.1 shows a beaker that contains molten sulfur at an initial temperature greater than 400 degrees Celsius. So you have to measure high temperature here by using thermocouple. On the figure 1, sketch the label, a diagram of thermocouple that is used to determine the temperature of the sulfur as it cools in the room temperature. Suppose here box with some ice. Ice cube. Now here suppose to a rod, metal rod conducting heat. Metal rods and having different materials connecting with some, suppose it's a conductor. In that thermometer is connected. By using this thermometer, that means here this is a ammeter. This is a ammeter. This, because of the different temperature terminal is inserted by two different metals, and those terminals are connected serially with series with ammeter. It shows some current flows through. This is by Seebeck effect. By using this method, we can measure the high temperature material in one side. Other here, this temperature, we know that. This is a simple diagram for thermocouple. Describe briefly how the temperature of the sulfur in the beaker is deduced. Measuring EMF. Here, this multimeter, ammeter as well as voltmeter, we can use it by measuring EMF, electromotive force, through meter, through this ammeter as well as volt also can measure because it's a multimeter. EMF through through the meter. By using some graph. So for particular voltage, how much temperature, we know the basic graphs. So by using standard graph or table, we can measure the temperature. State one advantage of using thermocouple to measure temperature rather than using a liquid in glass thermometer. What is the use of that one? Measuring high temperature. Measuring high temperatures, wires do not melt. By measuring high temperature with other, by using liquid glass thermometer. Here, by measuring high temperature, it may damage the, it may melt the wire. It may melt the wire. Then the calibration is not accurate. So it is better to use thermocouple rather than other liquid in glass thermometer. Next question. Here this figure shows the kitchen tap that supplies instant boiling water. Instant boiling water means this pipe itself works as some water heater. Cold water passes over an electric immersion heater inside the tap. The boiling point of water is 100 degrees Celsius. State what is meant by boiling point. The boiling point means a liquid become a gas. At what temperature? Liquid at what temperature the liquid become a gas. Liquid a gas or gas mixture or water liquid gas mixture. The temperature is called boiling point. That means at what temperature the liquid becomes a liquid gas or liquid gas mixture. That temperature is called boiling point. For water, it is 100 degrees Celsius. The immersion heater is powered by the mains at a voltage 230 volt. When the tap is opened, the heater switches on. The current in the heater is 13 amps. Calculate the thermal energy produced by the heater in 60 seconds. Here, VIT energy is VIT. Calculate the thermal energy power. Thermal energy is VIT. Voltage is 230, current is 13, and for 60 seconds. You can calculate this 230 you can calculate by calculator this one. 230 into 13 into 60, which is equal 1.79 into 10 raised to 6 joules. It is approximately 1.8 into 10 power 6 joules. In kilojoule, you can say it is 1.8 into 10 power of 3 kilojoule. The specific heat capacity of water is 4200 joules per kg degree centigrade. The cold water that enters the tap is 22 degrees. Calculate the rate at which the water is at its boiling point emerge from the tap. For this, power equal heat energy or power equal to mc delta T. This M equal power by C delta T. This power is 1.8 1.8 1.8 into 10 power 6 over C is 4200. Delta T is change in temperature, that is 100 minus 22, which is equal 0.548 kg. 0.548 kg, but per second, that rate, that is mass per kg per second, is that is 0.548 over 60, which gives 9.13 into 10 raised to minus 3 kg per second. It is 9.13 into 10 power minus 3 kg per second. Per second, this much water, kg of water flows through the pipe. Next question. The metal tape is earthed. The metal tape is earthed and there is a fuse in the cable that connects the heater to the mains. Explain how the earth wire protects the user. If the tape becomes live, that means the current is flowing. It cable that means it's may dangerous to that the person using, because may shock may happen. For that, if high current passing, if high current passing, then fuse melt, and open the circuit and stops the current flow and stops the current flow. It is for safety. It is for safety. It is useful. That is for safety. That is fuse wire is useful for safety purpose. Explain how the fuse protects the circuit. By that means by melting by melting the fuse itself, the fuse wire, fuse wire itself. The current flow stops. And protects the circuit. Next question. Look at here. Look at this figure. This figure shows a road next to sea. On a sunny day, the sun warms the road. Describe how energy from the sun reaches the earth and warms the road. By three forms, that is by conduction, maybe any three forms: conduction of heat, convection, radiation. That means here air molecules heated this that means air molecules heated by the sunlight and touch the water and heats up the water, and also it conduct through, or by convection, that is what flow movement of air molecules, flow movement of air molecules, heated molecules here and there go and conducting the electric heat. As well, radiation means vibration of the molecules and increase the kinetic energy. That means by increasing the kinetic energy of what air molecules, it then heat is transferred. Next one, the temperature of the road is greater than the temperature of the sea. The surface of the road is black. Suggest one reason why the temperature of the road is greater than that of the sea. Because it is then road is a black surface. Road is black surface. So which are good absorber of heat, good absorber of heat radiation, and C is a poor, but seawater is poor absorber of heat. That is the reasons. The air above the road is heated by the warm road. Describe how this affects the molecules of the air. By convection, because look at here, density of air above decreases. The density of the air above, the density of air above the road decreases, is decrease density of the road decreases, that is because of its hot air, density of the air decreases. Then due to decrease of density, there is a partial vacuum created. Then air above the road, the air above the road is replaced by cool air, above the sea, above or from the sea. That means by convection. This method is convection of heat transfer. Next question. The cyclist traveling along the road notices that a cool breeze is blowing from the sea to the land. Explain how convection produces this breeze. You may include diagram if it helps your answer. That means the same procedure what you here. That means here above the road, above the road, above the road, density of water, density of air is reduced. Density of air is lesser than from then above the sea, above the sea. Therefore, by convection method, convection method of transfer, heat transfer, convection method of heat transfer, cool air blows from sea to land, sea to road. So the cyclist feels cool air. Now, suppose this is a sea here. This is a sea water. This is a land. And you can give some. So air like air blows. Next question. In figure, it is full-scale diagram of a small nail in front of thin converging lens. The line L represents the lens. Now, look at here, this is a scale, this is a 1 centimeter. Now, the focal length of the lens is 3 centimeter. Means here, this is the focal length. This is F and this is a 12. Here also, F is this is a 12. Now, first one, the ray of light parallel to XY are traveling towards the lens. Describe what happens to the light after it passes through the lens. Now let us draw this. Look at here. Any rays and passes through F. And one more ray always passes through the center of the lens to this point. Now extend this and this also. Now let us drop. Now we draw a ray diagram. Now the ray of light parallel to XY and traveling towards the light lens. Describe what happens to the light after it passes through the lens. Yeah, all the light rays after passing through the lens and it diverges and diverge and passing through other focus. Passing through other focus point. It then diverge or spread out, diverge or spread out from the point and the point of convergence xy and 3 meter from the lens. Now look at here, this goes diversion. It look like it come from this point. So it is a mark and label with if each two principal focuses will be pointed. By draw, we finish the drawing. Is state and explain whether I is real or virtual image. Virtual, real and virtual image. It's a real and virtual image. State the name of the lens when it is used this way. It is a convex lens or magnifying glass. or magnifying glass. Magnifying glass. Then next one, next question, that is question number 8. Shows two vertical cylindrical tubes, that is copper and cylindrical magnets held in the vacuum. That is a cylindrical magnet. The two tubes are plastic tubes and copper tubes. One tube is made of a plastic and other tube is made of copper. The two cylindrical tubes have identical dimensions. The magnetic field of the small cylindrical magnet is extremely strong. Initially, the magnet is at rest at the top of the plastic tube. The magnet is released and it falls through the plastic tube without experiencing a resistive forces. The magnet takes 0.67 seconds to fall to the lower end of the plastic tube. What happened? First, the mass of the magnet is 0.012 kg. Calculate the kinetic energy of the magnet when it reaches the lower end of the plastic tube. The first one, V equal to plus gt. Velocity, final velocity is initial velocity plus gravity into time. That is V equal 0 plus 10 into 0.67 second, which is equal 6.7 seconds. 6.7 meters per second. Final velocity is here. Calculate the kinetic energy of the magnet when it reaches the lower point. Now, kinetic energy formula half mv squared, because half mass is 1012 kg, velocity is 6.7 square, which is equal 0.226 times joules. Therefore, kinetic energy is 0.269 joules. The magnet is then held at the top of the copper tube and released. As it falls through the copper tube, an electric current is generated in the copper, because this is a permanent magnet is passing through the plastic tube. That magnetic field is not produced in the plastic tube. That is, there is no magnetic lines through the plastic tube. But if passed through the copper tube, some electricity is produced, because and magnetic lines is cut by that magnet passing through. So electricity is produced, that is resistive to the motion. That is, speed of the magnet is reduced here. So explain why there is a current in the copper. Because magnetic field lines are cut by moving magnet. Therefore, the electricity is produced. Therefore, then the current in the copper produces a magnetic field of its own in the tube. The magnet falls much more slowly in the copper tube than in the plastic tube. Explain why the magnetic falls more slowly in the copper tube. because of force of magnetic field due to force of magnetic field, current is produced. Current produced. This current opposes the change. This opposes it oppose the moment of magnet. So it slowed down. So it slows down. Next question. The combination of logic gates are used when digital signals are processed. Describe the difference between digital signal and an analog signal. You may include a diagram with the help. Yeah, a digital analog. Digital or discrete. The signals are discrete. Discrete means it's not continuous. Yeah, analog signals are continuous. Information in binary. It is in binary state. It is in binary from 0 seconds to 1 second. It's representing range of values. It have range of values. Now this signal, look at here, for suppose the signal passes like it is here, but this signal is continuous like. Now next question be here. Figure is truth table for a logic gate X. So what type of gate it is? It is a NOR gate. Name NOR gate. The figure may be like then here further you can write this one. Suppose the terminal AB gives the terminal Q. Here logic gate Y is identical to logic gate X. That draw a combination of logic gate X and Y that behaves like a OR gate. Label the input A, B and Q here. That is It's an OR gate. NOR gate symbols with two inputs joined. Next question. Here, two of the isotopes of hydrogen are hydrogen 2, that is 1H2, and hydrogen 3, 1H3. State one similarity on the composition of their nuclei. Here, same number of protons. Both hydrogen 2 and hydrogen 3 have same number of protons. These are isotopes having same number of protons. Describe how a nuclei of hydrogen 3 differs from the nucleus of hydrogen 2. Hydrogen 3 has one more neutron, that is hydrogen 3 have one more neutron than hydrogen 2. One more neutron. Then in a nuclear fusion reactor, a nucleus of hydrogen 2 fuses with a nucleus of hydrogen 3 at an extremely high temperature. This fusion reaction produces an isotope of element X and releases a neutron. Explain why an extremely high temperature is needed when forcing these two nuclei together. Why high temperature is needed? High temperature produces high kinetic energy. High temperature, of course, it produce high kinetic energy. High kinetic energy, that momentum of electron is increased. Therefore, momentum of particles increased highly. So large quantity of work needed. So of work needed. Using nucleide notation, complete the equation of this reaction. Yeah. 4, that is X, presence of element, 4, 2, or which is helium, 2, 4, or it is also a alpha particle. One alpha particle is like helium particle. Helium nucleus, 4. And one neutron plus one neutron is produced. Neutron have 0, 1. No other particle, only this particle here, helium particle or alpha particle plus one neutron particle. Suppose if you add both, look at your add both, 2 plus 0 is 2, 4 plus 1 is 5. Here 1 plus 1 is 2, 2 plus 3 is 5. So far we discussed about physics extended theory of IGCSE. We have done. Please subscribe our YouTube channel.